Have you ever just wished you could peek inside an AI's brain? Not just see what it does, but really understand why it's doing it? Well, today we're diving into a really cool breakthrough called the ReAct framework. It's all about teaching AI to tackle complex problems in a way that looks a lot more, well, human. It's about connecting thought with action.
And to really get what this means, let's start with something super familiar. Just picture yourself in the kitchen about to cook a dish you've never made before. How do you actually do it? I mean, you don't just blindly follow the recipe word for word without thinking, right?
Of course not. You're constantly mixing together your thoughts and your actions. You think, okay, first things first, I need to get the pot hot. So you act. You turn on the stove. Then you look around and observe. Shoot, I'm out of salt. And right away you rethink your plan. No big deal, I'll just use soy sauce instead. For us, this cycle is totally second nature. But for AI, this has been a huge, huge hurdle.
All right, so let's get into it. Here's what we're going to cover. First up, we'll look at two classic AI styles, the thinker and the doer, and see why they fall short. Then we'll talk about the very real hallucination problem. After that, we'll unpack the ReAct solution itself, see how it stacks up in the real world, and wrap up by asking the big question. Does this actually get us closer to an AI we can trust?
So to really appreciate why ReAct is such a game changer, we have to understand the problem it's solving. For a long time, AI has kind of been split into two camps for solving problems. You've got the thinkers, and you've got the doers. And turns out both have some pretty serious flaws. So on one hand, you have the thinker. Researchers call this a reason-only AI. You can think of it like a brilliant philosopher who can map out these amazing logical arguments in their head. It follows a chain of thought to work through a problem. But here's the catch. It's all happening inside a black box. It has no connection to the outside world. No way to check if its brilliant logic is actually based in reality. And that right there, that leads to a massive issue. When an AI can't ground its own thinking in actual facts, it starts making stuff up. This is what we call fact hallucination.
And here is a perfect, kind of scary example. An AI was asked what, besides its dedicated remote, could control Apple's old front row media software. The AI thought about it and said, well, iPhones and iPads control Apple TV, so they must be the answer. It sounds logical, doesn't it? Except it's totally wrong. The AI just invented a fact. It hallucinated a connection that just wasn't there.
So we're left with these two kind of broken models. You've got the thinker, who can reason its heart out but can't check its facts. And then you have the doer, the act-only model. This one can actually do things like search the web, but it has zero internal monologue, it can't plan, it can't reason, it just acts.
And this doer AI fails in its own special way. For example, when it was told to find a pepper shaker in a virtual kitchen, it tried to pick it up from a sink. But the pepper shaker wasn't there. And because it can't think about its failure, it just gets completely stuck, trying the same failed action again and again and again. All action, no thought. A total dead end.
Okay, so you've got one AI that's all thought and no action, and another that's all action and no thought. The solution almost seems obvious when you put it like that, doesn't it? What if you could just combine the two? Create an AI that can think and then act in a continuous loop. Well, that's exactly what the ReAct framework does.
The whole idea behind ReAct is just so human. It basically teaches a large language model to do two things, one after another. First, generate a reasoning trace, sort of like an inner voice, and then a specific action to take. It's literally teaching the AI to think out loud before it does anything.
And this creates this incredibly powerful and flexible loop. First, the AI has a thought, where it makes a plan. Second, it takes an action based on that plan, like searching a database. And third, it makes an observation, seeing what happened. And that new piece of information, it feeds directly into its next thought, making the whole process smarter and more dynamic. So let's go back to that tricky Apple remote question. With ReAct, the process is totally different. It starts with a thought. I should search for Apple remote and what program it controlled. It acts, it searches. It gets the result, front row. Then it thinks again. Great, now I need to find what else can control front row. Its first search for that comes up empty. But instead of hallucinating, it observes the failure and rethinks. Okay, that didn't work. I need to be more specific. I'll search for front row software, and that action leads it right to the correct answer, keyboard function keys. It saw it failed, figured out why, and tried a new path.
Okay, this sounds amazing on paper, but, the proof is in the pudding. Does it actually perform better? Well, the researchers put ReAct to the test on some seriously tough challenges. And honestly, the results are pretty jaw-dropping. For instance, on really complex questions that require fact-checking on Wikipedia, the old ACT-only model was right about 59% of the time. Not bad, but ReAct, because it can reason about what to search for and how to refine its search, bumps that accuracy up. That simple little loop of think, then act makes a real, measurable difference. But where it gets really crazy is in these complex interactive worlds. In a simulation where an AI had to navigate a house to do things like put a clean knife on the table, ReAct had a success rate of 71%. That doesn't just beat the old methods, it completely blows them out of the water. They were stuck down around 40%. The ability to make a plan and use some common sense was the absolute game changer. I mean, let's just sit with that for a second. A 34% absolute jump in success rate. And get this. This wasn't from some massive, expensive training process with thousands of examples. This incredible leap came from just showing the model 1 or 2 examples of how to do it. That's insane. And this isn't just something that works in clean, perfect simulations. It holds up in the messy real world too. They tested it on a web shopping task, where the AI had to browse a real online store. ReAct hit a 40% success rate, easily beating other, more complicated learning methods. Its internal reasoning helped it just cut through all the noise and find what it was looking for. So yeah, ReAct gets better scores on tests. But honestly, the implications here are so much bigger than just a report card. This is really about fundamentally changing our relationship with AI by making it something we can actually understand. When you pull it all together, the benefits are huge. ReAct gives us an AI that is way more interpretable. We can actually read its train of thought. That makes it more trustworthy because it shows us its work. It's more robust because it can reason its way out of a dead end. And this might be the wildest part, it's more controllable. Think about that. A person can literally go in, edit the AI's thought, and get it back on the right track. What this all boils down to is that ReAct starts to crack open that mysterious black box of AI. Instead of getting answers from some weird oracle that we just have to blindly accept, we get an open book. We get a partner whose reasoning we can see, we can understand, and we can even help guide. That is a massive leap forward toward building AI systems we can actually genuinely trust.
And this all leads us to a really powerful question about what's coming. By merging thinking and doing, we're not just building smarter tools anymore. We're creating potential partners that can help us solve problems. So, what happens next? What's possible when AI can not only think about our world, but can reliably and robustly act within it? The possibilities are just starting to open up.